This video introduces you to lines and angles. So we're going to look at a few different things. We're going to identify some lines, some angles. We're going to classify them. We're going to look at finding some different measures. So we're going to start by looking at a couple of vocabulary terms. The first one is space. And so you need to understand that when you're talking about space, the space for these different terms is going to extend in all directions, and that's going to extend indefinitely. So it's going to go on forever in every direction. When we talk about a plane, so that's going to be this flat surface that also extends indefinitely in every direction. Another term you're going to see is a point. A point is not going to have any length, width, or height, but it does have a location. And so you could have just a point on a graph, a point on a line, a point on a plane. It's going to have a location, but it's not going to have any of those other things. Okay. When you have a line, that's going to be a set of points that's going to extend in both directions. And so you can see here that we've got point A, point B, and this is a line because it's extending in both directions forever. So that's what those two arrows are going to tell us. We can name this in a couple of ways. So you might just see where it says line AB, and because of that word line, you would assume that it's a line. Or you could see the two letters for the point. So since it's got points A and B, that can tell you that it says line AB. And then above that, it's got this line symbol. So there's two different ways you could say that that's a line. A couple of different things that we might see is called a line segment. So a line segment is just a piece of a line. So you can see the difference here is that on the ends, it doesn't have those arrows. So it actually stops. It stops right here at A and it stops right here at B. Also, if you look, the difference is that above that AB, it doesn't have arrows. It's just got that ending line. A ray is part of a line also, but it has one side that ends, but then it has one side that does have the arrow. So it stops on one side, but then it continues on one side. And again, you can see that that symbol above the AB matches. Then we talk about an angle. So in an angle, that's made up of two rays. And so you can see here, I've got ray AB, and I've got ray BC. And those two rays are meeting at this point B. And so an angle is made up of two rays and they share this same endpoint. And that endpoint is called the vertex. When you name an angle, it's very important the order that you call out or the order that you write the points. And so you can see here, this is angle ABC. Notice the vertex is in the middle. You could also call this angle CBA, but the vertex is still in the middle. You would never call this angle BAC because if you followed that line, it wouldn't make sense. So calling it BAC and following that order, because A isn't the vertex, it wouldn't make sense. So let's look at some examples of trying to label some of these figures. So we want to label these as either a line, a ray, a line segment, or an angle. So if we looked at example 1, we can see that it extends on both sides. Since we've got these arrows here and here, that tells us that this is a line. And if we wanted to name this, we could say that it's line AC. You could also name this line CA, and that would be fine. Number 2, since it has two rays, this would be an angle. And if we wanted to name that, we would again need to make sure that we had that order correct. So we could name this either angle BAD or angle DAB. But if you look in both cases, that vertex is in the middle. Number 3, since it has one endpoint and one arrow, it's a ray. And we would call this ray BF because B is the endpoint and F is where it's extending. 4 has no arrows. It's just got 2 endpoints. So this would be a line segment. And this would be line segment GF. And again, we wouldn't put any arrows above that. We could also call this segment FG. Right, the next thing we want to look at is classifying angles. And we're going to look at different degree measures. So to measure an angle, we're going to use degrees. And it's used to measure these angles, and you'll see that we symbolize that with this small raised circle. So right here, this is 360 degrees, and that's all the way around from where you started to where you stopped. And depending on where you stop along the way, that's going to determine how many degrees you've rotated. So an angle is the amount of rotation. So if we know all the way around is 360. Well, if I start here and I only go halfway, that's 180 degrees. So a straight angle makes a straight line, and that's 180 degrees because it's halfway to 360. A right angle is 90 degrees because it is a quarter of the way. Okay, we have 2 more terms. An acute angle, that's going to be any angle that measures between 0 and 90 degrees. So anything that's small between 0 and 90. An obtuse angle is any angle that's between 90 and 180. So these are going to be your larger angles. Okay, so let's look at finding the measure of the angles first. So if we look at example 1, and it asks us to find angle XZW. So we want to make sure that when we're looking for this, we're marking it out correctly. So we want to follow those letters. So I want to go from X to Z to W. That's going to tell me my angle. So this is the amount of rotation for my angle. And I can see that that means it's 90 degrees. So 90 degrees. Then if I look at my next one, so VZX. So VZ X. Okay, so this is going to actually go from V all the way to X. So this entire rotation is going to represent that angle. So from V to here, that's 25. But I also need to go 90 more to get to that full rotation. So that means that to find this angle, I'm going to move 25 degrees, and then I'm also going to rotate 90 degrees. So that gives me a total of 115 degrees. So if I were to look at this angle by itself, it would look like this. All right, let's look at another example. So here, again, I've got BGA. So I'm going to go from B to G to A. And so that's this small angle here. And so BGA is this angle that would measure 35 degrees. Then I want to look at angle CGE. So from C to G to E. And so everything between those two rays is going to be my angle of rotation. And so I can see that it goes from here to here is 15, but then from here to here is 45. So that means to get my full rotation, I went 15 degrees, then an additional 45 degrees. So my total rotation is 60 degrees. Okay, now we're going to look at these and classify them as either acute, right, obtuse, or straight. So remember, acute is between 0 and 90. Right has to be 90. Obtuse is between 90 and 180. And then a straight angle is equal to 180. So when you see a 90-degree angle, you're going to be told that it's 90, or you're going to see this box. That box means 90 degrees. So since number 1 has a 90-degree angle, that automatically tells us that it's going to be a right angle. Number 2, this angle is smaller than 90 degrees because 90 degrees would make this corner angle here. So this one is smaller, which means that this is going to be an acute angle. Number 3, this is bigger than 90 degrees because a 90-degree angle would look like that. So that means that this is going to be an obtuse angle. And then 4 makes that straight line, and that straight line means I'm going to have a straight 180 degrees angle. Okay. The next two terms we're going to look at are what's called complementary and supplementary. Complementary angles are two angles that have a sum of 90 degrees. So that means that when you put them together, they're going to form this 90-degree angle. So if I combined 60 degrees and 30 degrees, this is 60 and this is 30, together they would make 90. Supplementary are going to be two angles that have a sum of 180. So that would be a straight line. So if I combined 125 degrees and 55 degrees, that would give me a total of 180 degrees. So this example says, find the indicated angle. Number 1 says, find the supplement of 61. So that means that we want to figure out what can I add to 61 that's going to give me 180. So the easiest way to do that when you see supplement is we're going to say 180 minus 61. And that's going to give us 119 degrees. Because what that means, if you wanted to think about it visually, supplement means it needs to be a straight line. And if I know I've got a 61-degree angle, this one would need to be 119. Oh, that is not the right number. 119 degrees to give us a full 180 degrees. So we're just trying to figure out what would need to go here to give us that full angle. So question 2, again, we would do 180 minus 119. And we clearly know that that would be 61 degrees. So 119 and 61 are supplemental angles. Okay, complement, remember complement means it's going to be 90 degrees together. So that means that I would take 90 minus 25, and that's going to give me 65 degrees. So if I wanted to visually see this, if I had 25-degree angle, I want to know what do I need to put here to get 90. That means 65 degrees would give me that 90-degree angle. Last one, find the complement of 97. Well, that's bigger than 90 degrees. Still going to do the same thing. 90 minus 97, and that leaves me with an angle of -7 degrees. You can have negative angles, and that's okay. That just means that you're moving in reverse. So visually, I know I need to have this 90 degrees. Well, change my color here. 97 would be a little bit, didn't want that to happen. Let's see if I can get that back. All right, 97 would be a little bit past 90. So this, say that's our 97. Well, in order to get 90 degrees, I need to go backwards. I need to go backwards about 7 degrees. So when you're going backwards in reverse with degrees, you're just going to make it negative. So if I take away, basically, that 7 degrees, it would get me back to that 90.